Hi there, John Cummins from Executive Medicine. We have an upcoming new tool to measure brain health across 5 domains, and therefore I thought it might be good to do some sessions on brain health, and this one will be on memory. So one thing is that we all lose some brain cells as we age, and there is some debate as to whether we can form new neurons. Some investigators believe that we can't, yet there is some research that suggests that in 2 areas of your brain that we can form new neurons. One is our sense of smell, our olfactory organ, which is pretty useful during this COVID pandemic where people do lose smell. And the other one is actually in our an organ that's involved in memory called the hippocampus, a small, tiny little seahorse-shaped organ deep in the brain matter. So one thing is clear, though, that as we age, we do lose neurons. And even if we can form new neurons in our hippocampus and our olfactory organ, it won't be enough to replace those that we use. So it's really important that we protect our brain neuron with all of the lifestyle things I mentioned in the last report, but also maximize our capacity there. And a fascinating book on the latter is a book that was published probably 8 or 10 years ago called The Brain That Changes Itself. It's well worth a read just to see how plastic our brains really are. So what's the hippocampus? It's deep in the brain. It can be measured in terms of its volume on MRI. And so when we consider whether someone may have Alzheimer's or other dementing illness, we can clinically request MRI volumetric measurements, but we don't do it in routine healthy people outside of research areas. So the hippocampus's role is to basically process and temporarily store memories. And then what it does is it feeds them into the cortex, the 4 millimeter layer of the brain, for long-term storage. And this whole process where a memory moves from hippocampus to long-term storage in the cortex can take up to a couple of years, where we're going backwards and forwards all the time. So with our short-term memory, we can hold probably 7 items. So this would be recalling, for example, the 4-digit ATM number. Someone else has given you a number and said, can you punch those into the ATM? You can also have a thing called working memory. And working memory is where, again, you store a memory for short-term use and draw up longer-term memories to support that. So I may be teaching someone a skill and I might be drawing up language memories. I might be drawing up visual memories so I can transmit that process to teach a person that skill. And as soon as that task is over, I drop the working memory component. There's also a part of memory where I experience something. So if I've been within the Notre Dame, then I have a personal experience of that memory, and the hippocampus is involved in my personal experience and dragging those memories back up again. However, if I learn by rote the Notre Dame is in Paris, the hippocampus is not involved in dragging that memory up again. So during deep sleep, deep non-dreaming sleep, we form this consolidation by using very high-speed electrical activity called ripples. And what the ripples do is they shut down the superficial sleep, dive us into long-term sleep, and this is how long-term memories are formed. And it's also important to know that long-term sleep is thought to be deep sleep, is thought to be really important for washing out the amyloid plaque, which is felt to be causative in Alzheimer's disease. So we also link neurons to each other. So for example, if we recollect memories, we will have vision and taste and hearing involved. And if the memory is really clear, and for example, these flashbulb memories, everything will happen in sequence as it happened in the original event. And a common cause for this is actually PTSD. So this is where the whole event is re-experienced as if it's just occurring. But we can also alter our memory often inadvertently, so that if we recall a memory and we don't get the sequence right, then, for example, the memory is relayed down in a slightly different appearance. So, for example, I may have a memory of my wife wearing a red dress outside of David Jones, but if I recall it was outside of Myers 2 years later, it will be relayed down as outside of Myers. So therefore, what I'm saying is that, we can't always rely on our long-term memory either. So what have we learned so far? That the hippocampus, a tiny organ, is very important for memory acquisition, for personal memory recall, and its size can be measured. The number of nerve cells that we have is finite. It may increase a little bit, but it's really important that we nourish ourselves with great health habits, especially sleep, as outlined in the previous topic. Long-term memories can disappear unless we use them, and they may also change if we inadvertently recall them incorrectly. So just some interesting bits about memory and the importance of actually nourishing our brain and looking after our brain cells, because they can't replace what we lose through aging.